Howdy and good day, fellers. We are continuing Unit 5 in Algebra, talking today about solving a system of equations. And the next three objectives, 38, 39, and 40, all start the same way. I can solve a system of equations. What changes is the method that we're going to use, okay? And today's method is going to be graphing. So since we're going to spend such a large part of our unit on a system of equations, let's talk about what that is, okay? I kind of mentioned when we kind of previewed the unit that a system is more than one equation, right? So here's an example. We've got y equals 1/3 x plus 1 and y equals negative 2x plus 8. Notice that these equations are written in slope-intercept form, okay? They have an x and a y, meaning they are graphable, which means that they have ordered pairs that are a solution, right? And if we just look at that y equals 1/3 x plus 1, what's the y-intercept to this equation, 1/3 x plus 1? 1. So we know that the point 0, 1 is a solution to y equals 1/3 x plus 1, right? Because it's got that y-intercept. Is 0, 1 also a solution to our second equation? No. You plug in 0, 1 for that, we get 1 equals 8, which of course isn't true. Okay? So we're not just looking for a solution to one of the equations, we're looking for the solution that works in both. Okay? And one method we have to do that is the graphing method. So we are going to graph this equation, slope-intercept form, nothing really fancy here, y equals 1/3 x plus 1, start with that y-intercept point, okay? And then use our slope 1/3 to find more points. Up 1/3, up 1/3, up 1/3. We've got 4 of them there. I recommend that you make more than just 2 points because accuracy in this is very important, okay? Accuracy is very important. So let's connect these 4 points here, make our line. And every ordered pair on that line is a solution to our first equation here, right? Now let's go to the second one. Y equals negative 2x plus 8. When we graph this equation, what are we going to be looking for that's going to identify the solution that works in both equations? Because our first line gave us everything that works in the first equation. Our second line will give us everything that works in the second one. What are we going to be looking for to find the ordered pair that works in both? Where they intersect, which is why accuracy is so important, because you want to make sure they intersect in the proper place. So 0, 8 for our y-intercept, and then down 2/1 for our slope. Going to continue this, and lo and behold, there we have it. Okay, the one location where these two lines intersect. And that one ordered pair, that single ordered pair, looks like 3, 2, is a solution to both of them. Okay? So it's really, nothing new. We've graphed equations before. We're just now applying it to this system of equations situation. Okay? Questions so far? All right, let's go to the second one. Y equals 5/6 x minus 3. We're going to graph this in green here so we can keep track of them. So our y-intercept is negative 3, and our slope is up 5/6. So up 5 on the y-axis, over 6 on the x-axis. There we are. And I don't really like that I only have 2 points here. I can't get a third point by going up and to the right because that takes me off the corner plane. So what else can I do? Instead of going up 5 and right 6, Brady?
You can start from the y-intercept and go down 5/6.
Right. Up 5 and right 6, a positive 5/6, is equal to down 5 and left 6, which is negative 5 over negative 6, right? Because a negative divided by a negative is a positive. We don't often go to the left in slope, but here we have a purpose for it. We want to get a third point, down 5/6, and there we have it, okay? In the first one, I did connect all those points. You don't have to. It actually might help you not to, just kind of keep it less cluttered, but that is your call, right? Those 3 points are solutions to that first equation. And now we're going to look at the solutions of the second one and see where they intersect. So y equals 3/2 x plus 1. We're going to start with our y-intercept of positive 1. And we're going to go up 3 over 2, up 3 over 2. And it's a good thing that I found that point on the left, because going up and to the right, these lines aren't going to cross, right? They're getting further apart here. So just like going down 5 and left 6 was the same as up 5 and right 6, I'm going to go down 3 and left 2 here to get some more points. Down 3 over 2, down 3 over 2, down 3 over 2. Bingo. Got it. Okay. The ordered pair, which looks like -6, -8. That works in both. Pretty nifty, huh? Can anyone think of a real life application where systems of equations might be a useful tool? Brent?
Roads.
Roads? How do you mean roads?
Like where two roads come in to make one.
Sure. Like if you're planning, if you're road construction and you're planning your bridges and your highway connections, everything like that. If there are two roads that are going to be crossing here, you're either going to need a stoplight or a bridge or something like that. And this is be able to predict where that's going to be. What else? Any other application do you think? Yeah.
Maybe where you're gonna put a building.
Sure. Again, planning. The last class brought up sales. The we'll call it 10 to 18-year-old market, maybe more 14 to 18-year-old market. You watch certain shows at certain times, right? So if they wanted to, for example, target boys, and the red equation here represents when boys typically watch TV or what channel, and the green represents the age group 14 to 18, where these two things meet is the point where boys aged 14 to 18 typically watch either channel or time or whatever. Okay, so they can target that advertising group for a particular product. Right? Just a couple applications there. Questions so far? Everyone with me?
Sure.
Great. Okay. Yes.
So we're basically just trying to find the point where they meet.
Not basically, exactly.
Okay.
Yes. Yep. And then down below this here, we have the definition of a system. We actually already kind of answered that key point question there. It says, where do the lines on each corner plane intersect? We wrote those order pairs down there. And then what does this mean? It's the one solution. The one solution to both equations. Okay. And defining a system of equations, it's basically when you've got multiple equations with multiple variables that all have the same value. Our focus is going to be on two equations with an x and a y. When you get to Algebra 2, you'll be solving three equations with an x, a y, and a z. And that is where you'll be introduced. Did you know that the coordinate plane has a z-axis to it also? The z-axis is like a three-dimensional. It's as if it came out from the origin and went whoo, straight back. Okay, so you'll learn about the z-axis when you get to Algebra 2. But anyway, a system of equations is when the variables in multiple equations have the same value. Just having two equations isn't a system. If the variables in those equations have the same value, now you've got that relationship, and that relationship we call a system. Okay? So kind of going the opposite way here in this particular one. It says, what is the solution to the system of equations to the right? Write the equation of each line and show the solution works in each. First of all, what is the solution to that system of graphed equations there? 4, 2. And we see that because that is where the lines intersect. And here's a great example, actually, of when we can use function notation. Remember f of x, g of x back in PO 20? Rather than me saying, okay, look at the line that goes up from left to right with the y-intercept of -3, that one there, you know, we can label this f of x. And so now when I say look at f of x, you know exactly which line I'm referring to. Okay? And then when we write this equation to check this answer, make sure it works, we can say the equation of the f of x line is what? Y equals what? Slope and y-intercept. What are they for f of x? Yeah.
The slope is 3 halves.
Okay.
Y-intercept is
Okay. So the equation for line f of x is y equals 3 halves x minus 3. We see it has a slope of going up 3 over 2. It crosses the y-axis at -3. And we're just going to be checking our work here by taking the ordered pair that we got as a solution, 4, 2, 4, 3, 4, 3, and plugging that in. So for y goes to 3, and then 3 halves times 4 minus 3. 3 halves times 4 is 6. And does 3 equal 6 minus 3? Yes, it does. Checks out. All right? Just a test, just a proof that 4, 3 works in the f of x line. And now if we label the other one g of x, so you know exactly which line g of x is, what's the equation for g of x? Look at the slope, look at the y-intercept. Y equals -1/2 x plus 5. Yep. And just like we did in the first equation, we're going to take that 4, 3. 3 equals -1/2 times 4 plus 5. Or 3 equals -2 plus 5. That is true. That checks out as well. Okay. You're in that awkward phase for a teacher where you're so quiet. I don't know if you get it, and that's why you're so quiet, or you don't get it, and that's why you're so quiet. You're still being so quiet. Oh, okay. Are we all good? Okay. All right. Well, the second page has more opportunities for you to practice, 4 of them, in fact, and it says solve each system by graphing and then show that you verified the solution works. I bet we can get one of these done together in class here. So which one would you like to do? 1, 2, 3, or 4? 3. That's the same one the last class picked. That's good. Well, it's fine. You're the only one to say anything. So that's good. Okay, so y equals -3/5 x minus 5, and y equals -2x plus 2. So we're going to highlight that in green so we can keep track of it here. Graphing this starting at -5 for our y-intercept, and we're going down 3, right 5. Down 3, right 5. I can only get one more point by going down and right. So just like how -3/5, which is the same thing as -3 divided by 5, down 3 over +5. What's that the same as doing if I were to go left here to get a third point? I can't get a third point going down and right. That's off the plane. Yeah? Up and left. Remember I talked before about that position of that sign doesn't make a difference. As long as there's one of them, the value is the same. So whether the negative sign is out in front of the whole fraction, like it is in the original equation, that's okay. That means a negative 3 over positive 5, down 3, right 5. That's the same as a positive 3 over negative 5, which is up 3 and left 5. Right? All those things mean the same thing. They're all going to be part of the same line. Our next equation, y equals negative 2x plus 2. We're going to start at positive 2. And we're going down 2 over 1, as our slope says. It looks like going up and left wasn't necessary anyway, because I'm going to hit this point right here. And there we have it. All right. Ours looks to be 5, negative 8. Okay. Now the directions do say to check your answer. So what I need you to do now is take that 5, negative 8, go back up to your first equation here, and just plug negative 8 in for y, 5 in for x, and verify it works. Okay? Negative 3/5 of a positive 5 is a negative 3. And does negative 8 equal negative 3 minus 5? Yes, checks out. Then go to your second equation and do the same thing. Plug in negative 8 for y. Negative 8 equals negative 2 times our x value of 5 plus 2. Does negative 8 equal negative 10 plus 2? Yes. And so it checks out. Okay. It isn't often that I get to use all 4 colors on a question. So when I do, you know it's a good one. There you go. Questions on this? Very good. Your homework is to finish the page. You got 3 more to do. Make sure you are checking as well as graphing. And this method works really well when you have your equations in slope-intercept form. And when the y-intercept is an integer value. That's not always going to be the case, which is why we have other methods to solve it. But when you've got a system in slope-intercept form, graphing works real slick. Okay? With gusto, that's how you math.